welcome from BizTalk 360 once again. Thank you, Divya and Mayank, for a wonderful session. I am Mekhala. I have been working in BizTalk 360 for more than 3 years as a lead QA and product support. As a team, we will be involved right from the requirement till the maintenance phase of the product. It's my pleasure to introduce our speakers, Jeff Hollan and Derek Lee. Jeff Hollan needs very less introduction by now, since he had given an interesting session yesterday, and he is here with us along with Derek Lee to give session about Azure Logic Apps and advanced integration patterns. Derek Lee is a program manager, Azure Scheduler and Logic Apps. His focus is mainly on user experience, new user funnel health, and customer retention. Once again, a warm welcome to our speakers. Stage is over to you. Thank you.
Good morning, everyone. This is exactly how you want to start your day, with me up here again. I can feel it in the room. As soon as you looked at your agendas and she came out and said, it's Jeff Hollan and Derek again, you guys were like, oh my freaking crap, this is out of control. But that's good. This is actually the session I am most excited for throughout this whole conference. No offense to Kevin, we've got a great session coming up at 11. But part of the reason I'm really excited is because we're going to share some content here that we have not shared elsewhere. Not necessarily super fancy secret stuff, but just information that generally we don't go into the detail on. But I do think it's important, especially for this audience, for this community, for this group here, to know some of these things. So to start with, this is going to be an advanced session on Logic Apps, but I will keep it, fairly friendly and simple. So we're going to go into some advanced concepts, but don't worry, if you've never tried Logic Apps before, you'll still be able to follow along. So we're going to start with today. I'm going to break down, and I want to talk a little bit about the Logic Apps architecture, how it's built and how it works behind the scenes in the cloud. We're going to go into some of the advanced constructs that are possible, and we've made improvements in for building a Logic app. Derek's going to walk us through things like adding parallels, doing some exception handling, some advanced operational options that give you more control over how your app executes. And then I get to go into our favorite topic, which is workflow expressions, and I have some Easter eggs in there as well. So stick around. So the first thing, I mentioned we're going to talk about architecture. And that's because often when you're building on a PaaS solution, it can feel a little bit like a black box, right? It's fantastic in some ways. You simply say something like, I'm going to drop a message in a queue, and then I want you to iterate over the items, send emails, add something to a database, and you push save, and you're done, right? You click save, and everything hopefully just executes. But it is a little bit of this black box thing where you click save in a Logic app, and then you cross your fingers, and most of the time, hopefully it does exactly what you expect. But what's frustrating is sometimes it doesn't do what you expect. Sometimes the behavior seems a little bit other than I guess what you expected would happen, and you're like, I don't know why it's doing this because I don't understand what's happening behind the scenes. So I feel very strongly that the more you understand about the underlying system, the more you understand what's happening behind the scenes, the better equipped you are to build solutions with the right patterns and also understand when behaviors may be different than what you expect. I think all of us potentially have had experiences in our life where we don't understand something. This pretty much sums up my experience in high school, honestly, especially with dating, where it's just like, I don't understand. I think I'm doing the same things, I'm doing the right things, but I'm not getting the results that I expect. We'll go into more of that later. I'll just leave it at that. Okay, so the Logic app's actually made up of 3 components. I only have slides for 2 of them. I'll only briefly mention the third. But the first piece is the Logic App Designer. And the Logic App Designer, this is the part that you're probably more familiar with at this point, given some of the demos. This is this nice visual designer that you have to build your workflows. This is one of the great things about Logic Apps, is that it does a lot of great things for you automatically. It automatically generates the correct inputs and outputs, can do simple mapping, lets you do control flow. But let me explain a little bit about how the designer works and what it's made up of. So the Logic App Designer is a TypeScript, JavaScript, or React app. So Facebook has a framework for building TypeScript applications called the React.js, and that's actually what the designer is. So on your browser, on your device, that app is running fully. Everything you need is running inside of your own browser to do all of the designer things. You just download that JavaScript app or TypeScript app, and then it runs on your browser. And this is what enables us to do things like host the designer within Visual Studio, have the designer be hosted in other clients like Power Apps or Microsoft Flow, is because it is this contained app in itself, this TypeScript app. In terms of generating those nice inputs and outputs, so that if I'm saying send an email, I may see a to field, a from field, and a subject field. All of that is just generated by looking at OpenAPI or Swagger to render the inputs and outputs. So if you're not familiar, Swagger gives you a way to describe an API, explain what its operations are, what the inputs and outputs are. All this TypeScript app is doing is it's going and looking at Swagger for different connectors or operations and rendering the card. That's pretty much all it's doing. And then on top of it, obviously, it is doing some dependency and graph management so you can chain things together. But at its core, the designer is pretty simple. Obviously, there's some complexity baked in to do more advanced things, but it's really just saying, go look at these different Swagger documents, render them cleanly, let me build a graph, and that's all it does. Obviously, why it's valuable, though, is because of this last step, which is that it generates a workflow definition. So unfortunately, you can't take a screenshot of a Logic app and publish that to Azure and expect that the backend will know what to do with it, because the backend doesn't read pictures. So the designer generates this workflow definition, which is a big JSON object, which is pretty much just the data model for your workflow. And it generates that because that's what gets published into Azure, and that's what the backend reads and understands and knows how to process. So that's the designer. It's pretty much separated from everything else. Its job is just generate a valid workflow definition so that you don't have to write this workflow definition by hand. And you can see that workflow definition when you click that code view button in a Logic app. You'll see what it's generating. Okay, so now let's talk about the second component, which is actually the Logic app runtime. So this is the thing that actually executes your Logic app after you've designed it. So what it does is it looks at that workflow definition that the designer has created, and it breaks it down into a series of different tasks. So each of those different boxes within a workflow is a task. So it looks at that definition, it says, okay, I've got 50 tasks in this workflow, and then it will chain dependencies as well. So I can't execute task 38 until tasks 1 through 37 are done first. And maybe I can do task 2 at the same time I do task 1. So that's the first thing it does. It kind of looks at this, breaks it into a series of tasks, and understands the dependencies with it. How it works behind the scenes is we do have a distributed model where any worker across a vast series of compute nodes can complete those tasks. So that distributed nature is very important because it explains some of the behaviors on how your Logic app executes, including this, what was mentioned briefly in the last session, at least once guaranteed execution. So when you're using a distributed model and we're assigning different workers to accomplish different tasks across an entire scale set of virtual machines and compute clusters, it means that we can't take your workflow and say, we will only ever do an action once and only once. In the vast majority of the time, that's what happens. But we'll see as I break into this later, you do have at least once guaranteed execution and not only once guaranteed execution. But we do guarantee you will at least get one execution. There is no active thread management. Since this is distributed, we're really just assigning tasks in a distributed model. It means that you can have tasks and runs that are running in parallel at massive scale, because we'll just spin up workers across the entire cloud to accomplish your work. So if you want to trigger off thousands of runs, and those thousands of runs need to happen at the same time, that's fine, because we're just going to assign thousands of workers across the cloud to do that work for you. So that's from a high level. Let me break this down and walk it through kind of step by step. So this is an example of a workflow. It's very simple. It's going to get a message from a service bus queue. It's going to do the peak lock pattern so that it doesn't erase the message from the queue. It just locks it and says, I'm going to process this. And let's say that this message is an order, like an order from a grocery store, to keep the example simple, okay? So that order will have many line items, maybe bread, eggs, milk, okay? So the first step in my workflow is a for each loop, and it will say for each line item. For each line item, insert a row into SQL. So when this runs, after it gets a message, let's say I have eggs, bread, and milk, it will do an insert row, once for eggs, once for bread, once for milk. So I'm going to have 3 inserts. Once all of those are done, it has the last step, which is complete the message, which says, I successfully processed it, mark this message is gone so nobody else picks it up. So let's see what happens here in the Logic app when I run this. So the first thing I do is I click that Save button in the designer, and our designer is going to generate this workflow definition language. And it's going to take that workflow definition, that JSON object, the kind of the code view representation of these 4 steps, and it's going to push that into the cloud. And the first thing that's going to start off is it's going to break this into a series of tasks, and often the very first worker that we assign is a trigger task, because I have a trigger here when a message is assigned in a queue. So we're going to say, hey, we need a trigger task. We've got a bunch of work for you to do, and the trigger task is so excited. It's like, yes, my life's purpose. I'm ready to go. All of these workers have very strong personalities as well. I personify them. It makes me feel more connected. Okay, so this trigger task is excited. It's ready to go. And we tell that trigger task, your job is to go check Service Bus for new messages. And maybe I've defined an interval. Maybe I say, hey, trigger task, every 3 minutes you need to wake up, go talk to Service Bus, see if there's a message, and then come back and go back to sleep. With Service Bus specifically, if I set this to 30 seconds, we'll actually long poll for 30 seconds. So this trigger task will listen for 30 seconds to Service Bus, immediately listen for another 30 seconds, and immediately listen. So pretty much this trigger task is just constantly listening to Service Bus, waiting desperately for a message. Check, nothing, check, nothing. It's a very sad life if you never drop a queue item, honestly. So I feel bad for all these dev logic apps where people are just testing it out and they never drop that queue item, and this poor trigger task lives out its life just checking. But if he believes hard enough, and if everything aligns just right, and a message does get dropped in that queue, the trigger is going to see it. It's going to be so excited, and it's going to say, great, I have a message, so now I need to go and start a run. Now, there's kind of a break point in this life cycle of a logic app because our trigger's now told us that there needs to be a run. But does this trigger now get to take some time off, spend time with its family, maybe have a nice cake to celebrate? The answer is no. This trigger goes right back to work. And during the whole rest of this, just remember, this trigger task is always just working away. So because this is distributed and can be parallel, your trigger task is always just running away. So it might be firing off a bunch of other logic apps while we go through this single one. But there is a new run. So we have a new message. And so it notifies the workflow orchestrator, which is this massive service in the cloud that makes sure everything gets done in the right order. And so the workflow orchestrator now looks at this breakdown of tasks, and it says, okay, the first action that I can run right now that doesn't have any other dependencies is this for each action. So it assigns a worker, and it says, okay, for each action, I need you to go do your work. Let me know when you're done. So the for each action starts, and that task starts, and the first thing this for each action says is, what do I need to do? And it sees that it only has one thing to do, which is insert a row. Now, this is an important concept to know. By default, what this for each action is going to do is it is going to say, here's all the rows that I have, just have tasks execute all of them. Which means that you might have a bunch of workers that all in parallel will pick up work items and do them at the same time. So this isn't a for each loop that you're traditionally used to where you can say X++ and it just kind of goes like this one at a time. By default, it will do this in parallel. Now we actually limit it and we say we'll only ever let 20 workers at a time execute your tasks. But this is one that hangs people up sometimes because they have a for each loop and they're like, why is this all, like, why are things happening at the same time? And it's because we've just said, look, this is all the work I need to be done, and a bunch of workers at the same time pick it up and they all do their stuff independently, limited to 20. We are working on a feature right now where you could control exactly how many workers you want between like 1 and 50 to be working in parallel on your collections. And once all of those individual SQL insert tasks are done, they let the for each thing know. And once the for each thing says that everybody's taking care of all its tasks, it lets the orchestrator know, which going down the line says, okay, well, my next step here is to do complete a message task. And so it assigns that task, it wakes up, does its stuff, and then it finishes the workflow. Just a few things to point out here in case they weren't clear. The for each task could be done on a completely different machine than the complete message task. And my workflow orchestrator might be on a completely different machine than my trigger task. You have no guarantee where your stuff's going to be executed, just that it will be executed. And we will execute it. Okay? This is a very, the history of the workflow orchestrator is long and rich. It's the same orchestrator technology that powers every single Azure deployment in the Azure cloud, that Azure Resource Manager. So it is a very advanced technology to make sure things are completed, but they will be completed in different spots. And this has some benefits too, because I know when I talk to customers who are looking into Logic Apps, one of the questions they always give me is, well, what happens, like, look, we know the cloud is great and we know it should never fail, but what happens if the machine that my Logic App is running on reboots? Maybe it has a required Windows update that you can't postpone anymore, and it finally just kills in the middle of an important workflow, okay? And that's what they ask me. And if you understand that, look, it's not necessarily a single machine, even if one of these nodes individually fails, another node or another orchestrator across our replication system will notice that something didn't get done and take care of it. So actually, just to illustrate that point, I'm going to drill into this complete message. And let's show you a little bit more about task resiliency. So let's say on this complete message task, he's running along, living his happy life, and then something happens, okay? A failure of some kind occurs. So there's two kinds of failures. The first one is the more nice failure. This is that the task itself didn't fail. Maybe the thing it was talking to had an issue. Maybe it was trying to insert a row into SQL, and there was a DNS error returned. It said, I can't resolve this fully qualified domain name or something. Okay, so that's a kind of error. Maybe the connector is being throttled. Maybe you've been inserting so much stuff that the SQL service is saying slow down. Or maybe you get a nasty 500 internal server error, which isn't the task that had an issue. It was a server error saying, SQL's having an issue. Well, in that case, we have what's called a retry policy, where this task isn't just going to be like, well, the internet had a hiccup, I'm giving up, it's failed. But it will actually wait for a few seconds, by default 20 seconds, and try again. And if it fails again, it will wait for another 20 seconds and try again, and wait for another 20 seconds and try again, and do that 4 times. Okay? And this allows it so that if the series of tubes that is the internet has a hiccup, at least your workflow doesn't fail. So it will kind of be able to auto-recover automatically, and you can configure the behavior of your retry policy as well. The other type of failure would be, let's say maybe SQL's up and SQL is fine, but the task itself just died. For whatever reason, we said, hey, task, go accomplish this item. And while the task was going, it just vanished. Maybe it abandoned ship and it went to go be a worker on the functions team. I don't know. I don't know how these task lives work. But it could happen, okay? So what happens in that case is the workflow orchestrator is going to be like, hey, I assigned someone to go do this work ages ago. I haven't heard from him. He might have abandoned ship. So what the workflow orchestrator will do is assign a new task, assign another worker to accomplish that. And that's why you get this at least once guarantee. Because if that happens, it's possible that your first task actually succeeded. Maybe it successfully inserted that row into SQL, and then for whatever reason wasn't able to get the message back down the line. In that case, you might have 2 things that both inserted the same item into SQL, and in that case, you would get, double stuff. So again, this is very, very rare. For the most part, our tasks are very loyal to us. They love us, and they always report back. But it is something to be aware of, that is the behavior, is that if we don't get a response back from a task, we will deploy another one, which gives you that at least once guarantee. Okay, and then the third part of the, so this is the runtime. Hopefully that makes sense of how the model works. The last part is the connectors. And I actually don't have a slide for this, but it is worth calling out. Because in this case, we have a service bus connector and a SQL connector and so on. Connectors are more simple in some ways, but connectors are hosted and run separately than this runtime itself. So that is one important note to know. And it also is worth knowing that those connectors, many of them, like Dynamics for Operations, Dynamics CRM, they're actually built and hosted and supported by the partners themselves. So Dynamics team manages the Dynamics connector. They make sure that it scales up and it's able to accomplish the work that it needs. We work with the service bus team on the service bus connector, the SQL, and so forth. But what that also means sometimes is I got an email this week where today the Dynamics connector had a specific throttle set, where the Dynamics API said, I want to only allow a certain amount of requests per minute. And after that amount per minute, I'm going to start having to return a slowdown 429 throttle response. Now, if you hit one of those responses, you'll be able to see it in your monitoring view. We document all of the connectors and their throttle limits. But the one thing I do want to point out, we're constantly working with the connectors and the different partners to help them lift any limits and make sure that they scale up to whatever our customers want. But it isn't necessarily that these workers aren't able to scale. It's not that we hit our limit and we can't assign any more work. It's really that the connector itself is saying, look, I don't want you to DDoS dynamics. You can't insert a million things at a time or else you're going to tip everything over for everyone. So that's kind of some detail into where the scaling comes from. So I know that was a lot of detail. I know that's just how you wanted to start your morning. I wanted to make sure we did this one first so everyone was still wide awake for this kind of boring architecture walkthrough. But hopefully that's helpful as well, so that as you're building these workflows, you understand how they work, the guarantees that you have, and the power behind this workflow orchestration, so that we do guarantee. I check with my architect, and this is a fact, at least as far as we know, we have never started a run, ever in the history of Logic Apps for like 2+ years. We have never started a run where each task was not eventually executed. Okay, it hasn't happened, okay? Just because of all the state and the snapshots and the check, and we're always making sure that things are complete. So if we start a run, it will execute at least once as soon as possible, okay? All right, so with that, I'm going to switch it over to Derek, and Derek's going to give us some demos of how we can do some more advanced patterns within Logic Apps Designer.
Cool. Thank you, Jeff. So we're going to continue our journey with controls of fitness. And you may remember from yesterday, Tord showed you that whenever supplies in our pro shops are low, sensors will trigger a logic app, which in turn calls into BizTalk server to order supplies from our suppliers. Now, these products that's ordered will eventually have to be delivered to the pro shop. And we want to make sure once they are delivered, we have stuff on standby to put them on the shelf immediately. Because every minute that we delay, meaning member walking into our pro shop and not finding what they want. So how can we use Logic App to enable that and everyone stay on track of all the deliveries? The tracking company or the delivery company will actually notify BizTalk server whenever a package is out for delivery. So BizTalk will in turn take that notification and drop a queue message into a service bus. And then today, we will be creating a Logic App to monitor that queue, find out whom we should notify about that shipment, and go from there. And in the process, we want to show you some tips and some new features that we have recently shipped, and hopefully you can get inspired by that. So let's switch to my Azure portal. Here I have an empty Logic App. And we're going to start by using a service bus queue trigger. Now we have two kinds of triggers here. We have the autocomplete, which retrieves the message and mark the message as complete. Then we have the pclock, like Jeff just mentioned, which will acquire a log on the message for a specific duration. We'll process the message. Once we have completed the message, we'll mark it as complete. Or if it's poison message, we'll put it into a dead letter queue so someone else can fix it and potentially resubmit it. So in this particular case, I will actually be using the pclock trigger here. I already have a service bus queue configured. I believe it's called Pro Shop Delivery. Now, whenever I build these Logic Apps, I want to start small and just to make sure my Logic App works before I add more functionality to it. It's a good way to make sure that your trigger works as expected before you spend too much time developing and having to spend even more time debugging and figure out what's the problem. So what I'm going to do here is just to complete the message immediately. So again, I will be searching for a service bus service. And I will be completing the message in a queue. When completing the message in a queue, you have to specify the queue name and the log token that you have acquired. Now, for this demo purpose, I will shorten the duration so we see the message as they come in. Here on my mobile phone, I actually have an app that will drop a message, so I just click the button. And you can see the message has already been retrieved by Logic Apps. If we open the run history view, here you can see the message that I just dropped into the service bus, and you see the message is being successfully completed. Now that we know the Logic App do have the ability to acquire the message from the queue that we want to monitor, let's add more functionality to it. Now I know steps I want to do in between may fail. So what I want to do is here to add a scope so I can encapsulate all the actions I want to take and look at the status as a whole, and depending on the outcome, take certain actions. So here I have a scope. What I'm gonna do first is to use a parse JSON action. Parse JSON action will allow you to specify the input and the schema for it, and with that, we'll be able to generate friendly tokens so you can consume easily in later steps. So here, I know I'll be using the content from the service bus message, and here in Visual Studio Code, I actually have a sample input that we'll be sending. This is pretty simple, it has 3 properties: shop ID, order ID, and schedule delivery date. I'm gonna use this generate schema function, providing a sample input, and you see we generate the schema for you. Now that I have tokens at my disposal, I'm gonna use a DocumentDB or CosmoDB connector to look up using the shop ID and find the corresponding email that I have to send this notification to. So I'll be choosing this get the document action from DocumentDB. I have a database already configured, so I'll just have to pick the right database and collection ID. And the document ID, or the ID that we'll be using for lookup, will be the shop ID here. All right. So next, we're gonna just simply send an email to whomever that is on file for that particular pro shop. So I will use Outlook 365 action. For the to field, I already know how my document looks like, so I'm simply gonna write an expression for it. So I know it's gonna be in the body of my get a document action. And I know the property will be called email. Again, if you don't know how to write this particular expression.
Single quote right after the T.
Thank you, Jeff. No worries. It happened. So if you don't know how to write this particular expression, again, you can use parse JSON to help you with that by generating the friendly tokens, or you can try out our expression editor. In the subject, I'm gonna say, your order is out for delivery. Now, why don't we add an order ID here? So I'm going to say it's scheduled to be delivered by this particular token. All right, so we added some functionality to it. Let me drop another message here and see if it works. So I'm going to close the designer, and let's just refresh. The message has made into the queue and got picked up by the Logic app. Oops, that is not it. All right, so what happened here is I provided with a shop ID, and the document DB isn't happy. It says not found. So this can happen whenever we mistakenly input the incorrect shop ID. What this means is it happened, and we just have to correctly handle that particular exception. What I'm going to do here is I'm going to insert a parallel action. So we give you this nice plus button in between each of the steps that you can create a parallel. And whenever the scope failed for any reason, I know the message is bad. And if the message is bad, I want to move the message into the dead letter queue. So again, I will be picking the queue name and the log token here. All right, so the Logic app is saved. I'm just gonna drop a few more invalid message here. Still doesn't like it. Oh, forgot to do one thing. Now we create a parallel, but we actually have to specify when that later message action will take effect. So let me switch back to designer really quick. I want to show you this configure run after option. It's just hidden inside this menu here. And you can specify how this action will execute. By default, all the action added will execute if the previous one have succeeded, which you see here. But in my particular case, I want it to run if it did not succeed. So let me just update my logic app really quick and just drop another message. Not quite there yet. There you go. So one thing you notice is that during your update to your logic app, if an instance has already started, it will obviously take the workflow definition at that present moment and execute using the workflow definition. So I just have to drop another message after it's saved so that my new update kicks in. So here, what happened is my action inside the scope failed, and my scope got marked as failed as well. But the subsequent action, which is to letter a message in a queue, still get executed because I say it will run after the previous action has failed. So this is how you can do exception handling in logic apps. Now, this is interesting, but whenever we put a message into a dead letter queue, why don't we let someone know that something wrong that has happened and a fix is required? So what I'm going to do here is I'm just going to add another action. And for my particular case, I will use an approval email. Now, the common usage for approval email is you have an action that you want to ask a particular set of users to say, do you approve or do you reject? And then you can have a condition to look at users' response and take action accordingly. I'm using this a little bit different. I'm simply having an act button to make sure that someone sees this email, acknowledge that they know there is a dead letter message in the queue that they have to fix. And I'm going to send that to Jeff. So send approval email is a webhook action, and by default, it can execute up to 90 days. Obviously, we don't want to wait that long because people will be wondering where the approaching bars are. So what I'm going to do here is I'm going to go into the settings page and specify a timeout. A timeout is a way for you to define how long you want this particular action to run. So here, I'm just going to say, oh, wait up to 15 seconds, and
you give me 15 seconds to acknowledge a failure?
Yes, Jeff.
The standards this team holds me to. Unreal.
What if Jeff do not respond in time? Obviously, we want to escalate. So here, I'm just going to use a regular send email action. So I'm going to say a message is not act in time. And I'm going to send that to Jim. One other thing I have to configure is I want to only send this email to Jim if Jeff did not respond in time. So I'm going to change the run after here to has timed out. So let's save that, and let's give it a try and see if Jeff can respond this in time.
Crap. Come on. Everyone turn off Wi-Fi right now. I need this.
All right. Looks
I
like
got the
it's
email.
happening.
It's loading. Come on. Did I already miss it?
you
It
go.
says it timeout. It's
No.
still loading.
Okay, looks like it has timed out. And the email has been sent to Jim. Now, this is extremely useful whenever you have a webhook action that goes out and you want to limit how long it takes. And actually, it's not only limited to webhook. Let's say you have an HTTP action that goes out to an external API that may return you a retry after header, but you don't want to wait that long and you just want to handle it as a timeout. This is your way of doing it. Now, there are a few things I also want to show. We recently added into the settings page a retry policy. So by default, we'll retry up to 4 times with 20 seconds in between. You will be able to modify that to your liking. You can say, I know my servers do not like me to retry more than once every minute. And you can specify it here by using this ISO time format. So I can say it's 1 minute interval for my retry. We also provide you a way to mark the trigger as a single instance. So if your trigger runs on a recurrent basis, let's say your trigger runs every minute, but the workflow actually takes 2 minutes to complete, we'll make sure that no 2 concurrent instances of your Logic app is running at any given time. And I think something that's not here, but will be available very soon, and as Jeff mentioned, for each loop runs by default with 20 degrees of parallelism. So we have 20 workers executing your items in a given array at any given time. You will be able to, with just a toggle, change that to be sequential. So we'll run 1 item at a time, and that is important when you want to make sure you process all the items in an array in a sequential fashion. And with that, I think that concludes my demo. And then
Great. Awesome job, Derek. That was great. I do want to spend a few minutes, because this is an important part, and we always have a lot of jokes, and that was honestly phenomenal, Derek. He did a great job showing the patterns there. Hopefully you get a sense for the types of patterns that you can do, and that was just a nice taste. But there is also this thing, and you've seen us use it a bit already, but you see it even more if you go into code view, of this concept called workflow expressions. And a workflow expression is any input that will dynamically change every time the workflow runs. So in Derek's example, he had the subject of this message was not act. That was a static string. He just typed that in. That will be this message was not act every time that workflow runs. But he also put in things like an order ID. The order ID is going to change every time it runs based on the order. So workflow expressions give you a way to talk about those types of actions so that the engine can go dynamically retrieve the value at runtime. So I'm going to do a little bit of a breakdown into workflow expressions. Here's a few common ones you might see. At trigger body, which gets the response body of the trigger. At body of an action gets the response body of an action. Those are the most common. At items gets the current item in a for each loop. So those are kind of the big 3. A few that you've seen us use already. At GUID gives you a randomly generated, or a GUID, whatever. They're not randomly generated, they're just GUIDs. UTC now gets you the time. You can do things like random to get a random number. JSON and XML can take a string and convert it into JSON or XML respectively, or between JSON and XML. And we have one that's form data value, for if you're working with any form data, you can pull out the value from your form. Now there are 4 symbols, or 4 sets of symbols that you will see in your workflow. There's the @ sign, there's parentheses, there's curly braces, and there's brackets. And it's often confusing where and why we're using some things in some places. So I just want to end this in the last 5 minutes by breaking down when you use the @ sign, when you use parentheses, when you use curly braces, especially the curly braces. Those things, it's like sometimes they're there, sometimes they're not. So let's explain it a little bit. So the @ sign is a reserved symbol to indicate an expression. It's only reserved if it's the first character of your string. So he wrote Jeff Hollan at Microsoft.com. The engine doesn't think that at Microsoft.com is an expression because it's in the middle. But if he did at Jeff Hollan to tag me on Twitter, that would be like, okay, what's the expression Jeff Hollan, which we have not built yet. I'm sure it will do something awesome. So if he wanted to do that, he would need to do @ to escape the @ sign, okay? So the @ sign is a reserved symbol to say this is an expression. So @UTC now. Parentheses are pretty easy. This is fairly standard. These encapsulate the expression parameters. So if you have something like @length, the parentheses would hold whatever you want to know the length of. If you said sum, the parentheses would have number 1 and number 2. So that's what parentheses are for, okay? So if your expression has parameters, your parentheses surround those parameters. This is the finicky one, these curly braces. And some of you may even know where I'm going with this, because I do not want anyone to have questions on when and where curly braces are used, so I'm going to tell you a story about me, okay? I told you I had a hard time in high school, all right? Fair enough. This is all you need to know for that. So these are my braces that I wore as a kid. This is me when I was actually 13, so I guess I wasn't in high school yet. But this shirt, I actually have a very good memory with this shirt because I was hanging out with some friends, trying to be cool as a teenager, not really understanding what I'm doing because life is a black box at that point. And I have a nervous tick. You've probably noticed I either like bite on my fingers or sometimes I put my shirt in my mouth, whatever. It's something I need to work on. So I was doing that with my friends, and I had this exact shirt on, and I was just kind of hanging out with my friends, trying to be cool, and I had my shirt in my mouth like this. And my shirt got stuck on my braces back here, like way back here. And the string, remember that, the string of my shirt was stuck on my braces, and I could not get it out. Like I was pulling and pulling, but it was all the way back there in the bracket. So I looked like a total idiot, and I was trying to act cool, but I was like, hey, you guys, I totally have my shirt stuck in my mouth. Can somebody get scissors or something? Everyone made fun of me. I was scarred for life. End of the day, I'm here now in front of you, so whatever. But anyway, so braces mean, whenever you see curly braces, you think me, and you think that string, because braces mean string. Whenever you see curly braces, it means this is a string. It is the exact same thing as saying @string, except it allows for what's called string interpolation. Now, why this matters is because if you have an int or a number, and you put that number in curly braces, that is now the string 1, which is different from the number 1. Just like the value true and false is different from the string true and false. So these curly braces are not always what you want, but they do allow for interpolation. So I actually have two inputs here. The first is this is, and then I do curly braces, and I add 1 and 1. So the string will be this is 2 when it evaluates. That is the exact same thing as doing @concat to concatenate. This is not, and then it would do 3 in that case as well. So those are the same thing. So be careful with those curly braces. They can be very convenient because it lets you drop in pieces of your string without having to do a big long concat. But it will stringify everything. It will stringify objects, it will stringify binary. You know how if you get a picture and you say open in Notepad, and it's like those weird random characters? That's what curly braces do, okay? So if you have a binary file and you put it in curly braces, we're gonna do the same thing as saying open in Notepad. So just remember that. And then the last one are brackets. And brackets are there because you saw Derek do it. This lets you parse a JSON object. So this first example, this is good, okay? You have a JSON object, maybe it has a person property, which has an address property, which has street name. That's totally cool to parse it this way. Person.address.street name to get the street of that person, okay? This is fine, it's very convenient. But it is important to know, it is not XPath. So you cannot get an XML object and say some property. That will fail, and the engine will say, I cannot parse this because it is not JSON. So if you have XML and you want to parse it, you can use the XPath expression. That one's totally cool. And you could write XPath and do like the this property, the is property, the good property. Or if you're really fancy and you like writing really long expressions, you could convert it to JSON and then parse it. But it's important to know these brackets can only be used to parse JSON. So don't use them to parse anything else or else you'll have an issue. Okay, so that's kind of a high level of the different property types. The last thing I'll just note, and then I'll turn it over to John because he's got a great session. Expressions are evaluated from the inside out, okay? So I have a really long expression here. I want to know if the display name contains Jeff, but contains is case sensitive. So if it's capital J Jeff or lowercase j Jeff, those will be evaluated differently. So I'm adding in a to_lower expression as well to lowercase the display name so that regardless of case, I know it's going to evaluate to true or false. So I just want to walk through quickly how this is evaluated at runtime. So the first thing that happens is it goes all the way to the innermost expression, which is trigger body, parsing user.displayName. So the engine's going to say, OK, I'm going to get their display name. So now at this point, the expression to the runtime looks like contains to lower capital J Jeff. OK? And it kind of winds its way back out. And the next thing it's going to do is it's going to do the to lower expression. So maybe if it was capital J Jeff, now it would be lowercase Jeff. And then finally, working its way out, the last piece that will be evaluated is the contains, at which it's going to see if it's true or false. And it's either going to return a true or a false. So that's what expressions are. We have that expression editor now to help you discover and write those expressions. We're almost complete with a feature that would let you break down expression evaluations similar to how I did here, where after a run completed, you could actually go see what all the pieces of your expression evaluated to. So we'll be doing that as well as letting you test these expressions within the designer. That will be coming this year, at least scheduled to. So with that, that's all that we have today. Thank you for being patient with us as we went a little over, but hopefully that was valuable for you as well. So thank you very much.